Today we will study surface chemistry, second last chapter of your physical chemistry. Two chapters are left: surface chemistry and kinetics from your physical chemistry. And so surface chemistry, this deals with the nature of surfaces, you can say, of solids and liquids, and also it deals with the physical and chemical processes on the surfaces. So in surface chemistry we'll study first it is your adsorption, since it deals with the nature of the surface. So here adsorption, this is a phenomena in which a substance, one kind of substance, gets accumulated means gathered, collected, accumulated on the surface of another substance. And this happens due to van der Waals forces. Van der Waals forces, you know, electrostatic forces of attraction between two dipoles, and so due to van der Waals forces between the substance which is getting accumulated on the other substance. And this van der Waals force, you have studied that this is a very weak force, and if I talk about the liquid, this is liquid, or you can take piece of solid. So a molecule which is at the center, this will be here, and this is surrounded by many other particles. So they are held together by different kind of forces. So the molecule which is here inside the bulk of the substance, that will be experiencing complete binding force. But the molecule which is on the surface of the substance, this will not have complete attractive force. So therefore they have unbalanced forces on the surface. Unbalanced forces on the surfaces. Surface of what? Surface of solid or the surface of a liquid. Surface of a solid or the surface of a liquid. So this unbalanced force is there, but inside the substance or the solid or maybe liquid, these forces are complete, but on the surface these forces are incomplete, as I showed you through the diagram. So because of incomplete your forces, a state of unsaturation. A state of unsaturation is developed on the surface. Unsaturation means what? Substance which is accumulated there on the surface, that will not be satisfying your substance over which it is getting deposited. So let me clean it. So because of a state of unsaturation, what happens? The substance from the bulk or the solid attracts other substances to balance these forces. The forces which are unbalanced, to balance that it is attracting other substances. So when it attracts, so here on the surface, these other particles which are attracted, then they will be establishing the bonding. So attracted particles form either physical or chemical bonding with the surface molecules. So when they are establishing the bonding with the surface molecule, then the substances which are attracted over these solids, their concentration is increasing. So that changes the concentration of substances on the surface. So we can define this your adsorption on the basis of the change of concentration, that adsorption is a phenomenon. So therefore it is adsorption. It is a phenomena of changing concentration on the surface of the solid or liquid. It is changing of concentration of the concentration on the surface of the solid and liquid. Why? Due to the action of residual unbalanced forces. So this is another definition of adsorption. So we'll see that here. Now we have two kinds of substances. One substance is getting accumulated over the other substance. So if I take this as a substance over which another substance is getting accumulated, like you take example, if I dip this finger into the ink. So ink particles will be settled on my finger and they will remain only on the surface. So it is a surface phenomena. So in that case, if I take this finger as the substance over which this is getting absorbed. So here this substance, this is called, so the two substances we have here, the substance which is here we have the substance that attracts, the substance that attracts the other substance here, and this is attracted substance. So attracted substance, this is attracted substance, this is called adsorbate. This is adsorbate and this is called adsorbent. So my finger is adsorbent and ink on it is your adsorbate. So it is a surface phenomena. Other examples of this you can see in your book given many. Very common example is bromine adsorbed over activated charcoal, and coloring colors, or if you take this sugar which is prepared in the mill commercially, that is not colorless, having some brownish yellowish color in it. So to make it colorless, that solution is passed through activated charcoal. So color, when it is colored substance when passed over activated charcoal, then color is absorbed by charcoal, adsorbed. And so like this many examples you will find in your book. One example I gave you, when you dip your finger in the ink and your skin is getting stained, but inside the finger is receiving no colors. Now we will take another phenomena that is also taking place, that is absorption, AB, absorption. Initially it was adsorption and AD, adsorption. So adsorption is this is your surface phenomena, and in absorption, that is your adsorbate particles, adsorbate substances penetrate into the bulk of the adsorbent. That is, if you take chalk, piece of chalk and chalk stick, and you dip into the ink, what will happen? The whole chalk will be stained. Inside it is penetrating, and so here chalk will be your adsorbent and ink will be your adsorbate. So in that case this is taking place, and these adsorbate substances, when they penetrate into it, they are spreading and occupying the space in the lattice of the solid, lattice of the substance. So here that is your absorption. Example one I gave you, chalk stick dip in your ink, and you can take another example very common, ammonia dissolved in water, ammonia is thoroughly going inside water and penetrating there. So many other examples of absorption you can get in your book. Then there is a phenomena called sorption. Sorption. When adsorption and absorption both take place simultaneously, both take place together, then the phenomena is called sorption. Okay. Now we will go to the next part. Adsorption of gases. Adsorption of gases on solids or liquids. So we will see the factor on which this adsorption of gases depend. The first factor is nature of adsorbent. Nature of adsorbent means the substance over which adsorption is going to take place. So in this, first thing is that they should have a high residual field forces. Unbalanced forces must be high. Then I hope you understand residual forces. That is unbalanced forces, that which I have considered earlier. Now the second is your high or larger surface area for adsorption. If this is your piece and this is your piece, this has larger surface area, so adsorption will be faster here, adsorption will be slower here. Then third is your state of subdivision of adsorbent must be high. Means what? Finely divided. Finely divided powder-like substances if you have. So if you take this big piece of adsorbent and then the same piece you crush and make into smaller pieces. So surface area, this is your surface area, only this much. And here this is the surface area, this is the surface area, all around also surface area has increased. So that is finely divided substances. So adsorption is directly proportional to the point A and the point B and the point C. Means adsorption is directly proportional to the residual field forces. Higher will be residual field force, then this adsorption will be more, faster, more it will be. And if the surface area of the adsorbent is more, then adsorption will be more. And if the substance that adsorbent is having very small parts, small particles, not a big lump, then also adsorption will increase. So this was the first factor on which the adsorption will depend. The second is nature of adsorbate. So here it is gases being adsorbed on solid. So here adsorbate is your gas. So the gas must have a high critical temperature. High critical temperature if they will have, then they can be easily liquefied. So gases with a high critical temperature, in class 11th you have studied that. High critical temperature can easily be liquefied. You can convert them into liquid very easily. And since they have a high critical temperature, can be liquefied easily, and therefore what will happen, adsorption will be faster. Okay, now, so when this critical temperature is high, one thing you remember, that is van der Waals forces. Van der Waals forces will be, van der Waals forces you people know, okay, van der Waals forces here, this is mentioned in your syllabus, that's what I was looking for, that students should know that nature of adsorbent that depends upon the critical temperature. And why? The critical temperature must be high, because at high, number one, they can easily be liquefied, and number two, that a van der Waals force or van der Waals forces are easily established. So this is there. Van der Waals forces increases because can be liquefied, so molecules are held together easily. Now the third factor is pressure. This is directly proportional. Higher the pressure, faster will be. So this is adsorption is directly proportional to pressure. This is important thing. But at higher pressure, adsorption attains a limiting value. Means beyond that, adsorption will not be possible. So very high pressure we cannot keep, although this is directly proportional. Then temperature is adsorption is inversely proportional to temperature. You will increase the temperature, and what will happen when you increase temperature? The adsorbed gases that will be given out. So these are the four factors on which adsorption of gas depends upon the solid. Now types of adsorption. Types of adsorption. So there are two types. One is physical adsorption and the other is chemical adsorption. Physical adsorption is also called physisorption or van der Waals adsorption. This is also called chemisorption. So we will compare these two. So the characteristic of the physical adsorption will see point twice. First point, in this case, van der Waals force is weak. Okay, van der Waals force is weak and no specific nature. No specific nature means any kind of substance can be absorbed, any gas can be absorbed, not only neutral or not only lighter or not heavier or not acid, so it's nature free. Any kind of gas can be absorbed. That if a gas is being absorbed on the surface, then it is physical adsorption if it is going through the weak van der Waals force. Then this is reversible. Reversible means what? Once gases are adsorbed, they can be removed out. If you decrease pressure, you have seen directly proportional to pressure. Adsorption is directly proportional to pressure. So if you decrease pressure, then the gases adsorbed will be given out. And temperature, you know that it is inversely proportional. Low you will keep temperature, this will be low, this will be higher. So if you want to remove the gases, you will have to increase pressure. So reaction will be reversible at low pressure and high temperature. So remember that. Okay, and then next point is exothermic. This process is exothermic, but enthalpy of adsorption is low. Enthalpy of it. So you remember that although it is exothermic, but enthalpy delta H adsorption, this is quite low. Then this is first point, this is second point, third point, fourth point, fifth point now. This is multi-layered in nature. Means what? If this is your adsorbent and over which one layer of adsorbate has stuck, then over that another layer, so multi-layered phenomena is this. So this was the fifth point. Now the sixth point, that is here we use just gases are there, so these gases physically means there will be no chemical reaction. If this is your adsorbent and one kind of gas is here, then other gas is coming over here to make another layer, so there will be no chemical reaction, only van der Waals forces will be there between these two kinds of your gases molecule. And this is inversely, that is physio adsorption, it is inversely proportional to temperature because van der Waals forces are stronger below critical temperature. This is one point. And the second point, activation energy, EA is called energy of activation. You will study in kinetics, last year also you have studied energy of activation of adsorption, energy of activation of adsorption. So this is 0. energy of activation of adsorption is 0. Therefore, what is there? Rate of adsorption does not get changed at low temperature. So low temperature, when you will keep physical adsorption or physisorption, that will be more. But if you keep temperature low, then what will happen? Your activation energy is 0, and activation energy is 0. So what will happen? There will be no change in the rate of the adsorption. So here, that is at low temperature this is taking place. These are the two reasons. Because if you keep temperature low, and if temperature goes lower than the critical temperature, so at the that happens what? You have written below critical temperature, van der Waals forces are becoming stronger. So gases can be liquefied easily, and so they can be adsorbed easily. So if you keep your temperature below critical temperature, this phenomena rate will increase. And at low temperature, what is happening? Activation energy is 0, and so once it has started getting adsorbed at low temperature, its rate will not be affected. Means the rate will not decrease, neither decrease nor increase. It will remain the same. So this was the 6 point. Then 7 point. It is directly proportional to the pressure. But at critical pressure rate of adsorption increases sharply. This is their 7 point. Then the 8 point, nature of the gas. If gases must have high critical temperature. High critical temperature means gases can be liquefied easily, so can be easily adsorbed. Now I will compare this point with chemisorption. The first point, if you look for here, van der Waals force is weak, but here we don't have van der Waals force at all. Here the force between adsorbate and adsorbate is your chemical force. Chemical force, that is your bonding. Let me change the pen. Chemical force, that is your valence bonding. So this is your physical force, electrostatic force of attraction. Your valence bonding means electrons are involved. Now the second point, if we compare, here it is no specific nature, but here it is specific. A specific nature. One kind of gas can be only absorbed, not all kind of, that is, so to one adsorbate, one particular kind of gas as adsorbate can be taken. This is reversible, so here it is irreversible. Once gases are adsorbed, cannot be removed. Here you saw by changing pressure, by decreasing pressure and increasing temperature, process could be reversed, but a process cannot be reversed. Here this is also exothermic, but enthalpy of adsorption is high. Here enthalpy or adsorption is low, and here enthalpy or absorption is high. This is multi-layered in nature. One adsorbent can be accumulated over the other, but here it is monolayered, one layered. One layered, not multi-layered. One layered in nature. Then it is inversely proportional to temperature. It is inversely proportional to temperature here because it is exothermic, because it is exothermic. Therefore, it should be favored at low temperature. But with the rise of temperature, rate of adsorption initially increases and then decreases. So this point you have to remember. Both are your exothermic. So it is directly, simply you keep temperature low, physical adsorption will take place. Here it should take place at low temperature, but what is there, because this is high, enthalpy or adsorption is high, although exothermic, but with the rise of temperature, so because of this, the higher temperature initially may increase, because what is there, that is here process is exothermic. So initially it may be it will increase because activation energy here which we have, that is high. Here activation energy was low, here activation energy is high. Therefore activation energy is high. Because of that, when temperature will increase, then initially to reach to that higher activation energy, you will see in kinetics what happened, that in the beginning when temperature is increasing, it is like uphill task when you have to climb on a hill. So activation energy you can understand like this. So up till here, this is your, if take the graph, and here is your this gases which have to be adsorbed. So when this much high energy they need, if this much energy they will have, then only they can be adsorbed. So to attain this, they have to be heated. So when they are heated in the beginning and once they attain this much of energy, they start getting adsorbed. Once they attain this much, after that still you increase temperature, since they have attained their activation energy, so what will happen? So much of the gas will not be absorbed, and what will happen? It will be downhill task. Means what? Adsorbed gases may be given out. And so for some time when we increase temperature, rate of adsorption increases, but after that it will start decreasing. So this you will understand on the basis of the graph which you will do in a kinetics chapter. So this was the 6th point that you have seen, that low temperature it has to be favored and all that what I explained. Now for the pressure it is the same. It is directly proportional to the pressure. It is same. This point is same. That is, it is directly proportional to pressure. Nature of the gas, they should have high critical temperature. Here nature of the gas, but it does not depend. It does not depend upon critical temperature, but upon valence bond. How the bond is formed, how much energy is required to establish the bond. So remember that. So these 2 points are important, 6 points and the 8 points. So this is about types of adsorption. My next topic will be catalyst. And so till then, bye.